All right, so we have a figure here for number 8, this one we're doing the proof on, and it starts off being just this. It's a circle. What are these lines called that are here? C, D, and B, A. What would you call those lines, guys? Those of you who want to go through the proof together.
It's not on this one.
Oh, thank you. Okay. So here we go. On number 8, we're given that in a circle we have 2 chords here, and if you notice, they mark them congruent. They put a line on each one of them. And so the given is in circle O, measure, I'm going to put given up here because that's what we know to be true. Measure of arc AB is equal to the measure of arc CD. So let's mark those in green. Just they're saying that the arcs are congruent. So this arc here is equal to this arc. And they want us to prove, oh, I put the red marks on the wrong thing, didn't I? Because they were supposed to be on the arcs. So let me make a green mark. This is congruent to this, and the red marks are what we're trying to prove, basically. So we're trying to prove that AB is equal to CD. We don't know it already. That's what we're trying to prove. I just marked the wrong thing. Okay, so we know the arcs are equal. So here we go. It says draw, so we're going to have to draw some stuff in, usually in a proof. If you think about the problems, we had to do this quite a bit. We had to draw stuff in to make a right triangle or something. And here we're going to make congruent triangles. So they're telling us to draw some stuff in. It says draw OA, draw OB. Aren't all these things I'm drawing so far radius? Each one is a radius of the circle, right? Draw OC and draw OD. Why can we draw these lines? What would be the reason for number 8? There's a funky name for it. What did you?
I got 2 points to terminate.
Yeah, that's fine. Something like that's fine. I think the book gives this a funky name, but basically you can say between any 2 points you can draw a line. Between any 2, or you can say exactly the way Charlotte did. That's fine too. Between any 2 points, there is a line. Or we can draw a line. Okay? Let me just put my reasons over here. Okay? All right. The next step says that OA is equal to OC. So let's mark as we go. OA, and put 2 lines on it, is equal to OC, and putting 2 lines on it. And then OB is equal to OD. I could mark those with 3 lines apiece. They're telling me how they want me to match some stuff up for a triangle. Aren't all of those, what's the reason I can say these things are equal? What are OA, OB, OC, and OD? They're all radii of the circle. So you could just put all radii are congruent. If you want to really abbreviate it, you could just, use some notation like that. So I could put 3 marks on OB and OD, but they're really equal to the other stuff too, so I'm just going to put 2 marks there. And it's just because they're radii, they're equal. They're kind of telling me, hey, you just drew some triangles. Here's really what they're saying here, and they're not saying it. You just drew 2 triangles. I'm going to show you we're going to match some sides up, and we're going to prove these triangles are congruent, and then we'll be able to say matching sides are congruent, basically. Okay, so that's kind of where they're going with this. 10 says the measure of arc AB is equal to the angle AOB, and the measure of arc CD is equal to angle COD. Why is that true?
The arc is equal to the central angle.
Arcs and central angles are congruent, right? The arc that the central angle cuts off is equal to its central angle, so we'll say central angles congruent to their arcs. I'll just put it that way. You can give the reasons without getting all booky, you know what I mean? You can just abbreviate it and put it in your own words. Okay, 11 says, because arc AB, the measure of arc AB is equal to the measure of arc CD. That's what they gave us, so that was the given. Because that was given, then angle AOB is congruent to angle AOC. How do we know that?
Is it the same thing as 10 that,
Well, they told us that these things are equal to the central angles are equal to their arc, you know. But if you kind of put all that information together, they're kind of taking, let me circle it. Aren't they taking the fact that these two are equal, so that must mean these two are equal. Wouldn't that be either substitution or the transitive property, either one of those? Yeah, because they said they were equal. They stated all this stuff in the previous one, and so they're just taking two pieces that were equal to equal pieces and setting them equal. So you could say substitution or you could say transitive property, whichever you prefer. I'm going to say, yeah, you can, either one will work. Let's just say, I think y'all probably understand the idea of substitution, so we'll put that down. Those angles are in the triangle, so let's go mark it. Let me use a yellow or something to color it in. We just said that AOB, this angle, is congruent to AOC. Wait, no. AOB is congruent to, I miswrote that. That's supposed to be COD, isn't it? It's supposed to be COD there. I copied off the wrong line. This should be angle COD, and that angle is right here. Is where I wanted it to be, because I want to be able to say we have congruent triangles now. That's what they're getting at. Do we have enough information to say these triangles are congruent already?
by SSS?
Well, we're trying to prove that third side,
Oh.
but we do have two sides, and we have the angle in between them, right?
Mm-hmm.
So wouldn't that be side angle side would be the reason that these two triangles are congruent?
Yeah. Mm-hmm.
Because you got all these sides with these two marks on them. So, and if you remember, they were telling us to match up OA with OC and OB with OD, and we just got the angle that's in between all those, so that would be, they're congruent by side angle side. So all these triangle things are showing up in these circles, and that's how you use circles, like in pre-calculus and trig, that's exactly how you use them. Since all those triangles are congruent, don't their matching parts end up being congruent too?
Mm-hmm.
So that's why we can say that A, B, and C, D are equal, because they're matching parts. What was the way I said that? I'm going to have to put it up here. You remember, how did we word that? There was a theorem. Corresponding parts are congruent, triangles are congruent, and we just use it so much in geometry that CPCTC, yeah. So that you just always abbreviate it because it's such a pain to write it out. CPCTC, if you can't read that. I need to use a thicker marker on here, but if I use a thicker marker, I can't get it all on a page.